Hello, welcome back to another problem on the simplex method. So this is another standard max problem. We are maximizing an objective function subjected to a bunch of linear inequalities with less than or equal to signs. And I did forget that your variables have to be non-negative. Okay, so now here are all of our inequalities. Now let's start setting up the simplex table. First thing we need to do, we need to introduce our slack variables. So we're going to take each inequality and add a slack variable, like this one right here, u, so that I can turn them into an equation. Alright, so there's our first one. Let's take a look at the second one. So I have my x plus 3y plus 2z plus v. So here's my second slack variable, v. And then I have one more inequality, which is 2x plus y plus 2z now plus w for my additional slack variable. So now we have three slack variables, u, v, and w. Okay, so I have my slack variables. Step 2, we need to rewrite the objective function. So my objective function, 6x plus 5y plus 4z, we're going to do is we're going to subtract them all over with the p. And there we go. So negative 6x minus 5y minus 4z plus p equals 0. So now I have my slack variables, I have my objective function, so let's set up the simplex table. So I have my simplex table set up over here, and I'm going to take all the coefficients from these equations and my objective function. Remember, the objective function will go down here. So write all the coefficients in my table. And there we go. There is our initial simplex table. So these I guess are steps 1 and 2. So I guess step 3 would be to find the most negative entry in our last row, which would be the negative 6. So this is going to be our pivot column. We now got to figure out what is our pivot row. So you're going to come over here, and we're going to divide the constant, so like 180, divided by 2, because again the corresponding entry in the pivot column, that gets me 90, and then you do 300 divided by 1, that's 300, and then 240 divided by the 2, and that's 120. So which one is the smallest ratio? It would be the 90, so this would be my pivot row, and then this will be my pivot column. Okay, so I'm going to clean all this up. I'm going to put this table up top, and we'll get started. Okay, first we need to change this into a 1. Now, how are we going to do that? We are going to multiply row 1 by a half. And so I'm going to get a 1, and then all of these are going to be 1/2s. 0, 0, 0, and 90. Now I'm not changing anything to the second, third, and fourth row, so I'll just write those in there again. Okay, almost done. Alright, so again, this is my pivot element right here. Now we need to make these zeros. Alright, so let's go ahead and do that. Let's scroll up. Alright, so let's bring out another table. I'm going to rewrite our first row because that row is not going to change. But we are going to do row operations now on rows 2, 3, and 4. So, row 2, since it's a 1, I need it to become a 0. What I'm going to do is I'm going to take row 2, the row I want to change, row I want to change, and I'm going to subtract off 1 times row, because again, if it's a 1, I need a negative 1 times row 1, our pivot row. So again, this is what we're pivoting around. And then if you followed along in the last video, you can use a calculator, which is extremely useful in finding our row. So let me pull that calculator back out just to show everyone again. So what we're going to do is type in exactly what we see here. So it says row 2. So let's go ahead and type in row 2. That's a 1, 3, 2, 0, 1, 0, 0, 300. We're going to close that off, and then we're going to minus 1 times row 1. All right, so let's go ahead and type in what row 1 is. So a bunch of 1/2s, zeros, and then 90. Okay, we're going to close that off, press enter, change them to fractions, and there we go. So this is my new row 2 that I have right here. All right, so let me take this off screen and I'll put in our new row. Okay, row 2 is done. Let's take a look at row 3. We have a 2 here. I need that to become a 0. So what I'm going to take is row 3, the row I want to change, subtract off 2 times row 1. All right, if we take out that calculator again, okay, let's enter in row 3. And we're going to subtract 2 times row 1. Again, my pivot row. We're going to press enter. And there we go. There's my new row 3. So let's go ahead and put that into the table. So we got 0, 0, 1, negative 1, 0, 1, 0, and 60. All right, the last one. So we got row 4. Now it's a negative 6, so we're going to need a positive 6 times row 1. We'll do the same thing, but what we're going to get, and because I don't think I have to show you again, we're going to get a 0, negative 2, a negative 1, 3, 0, 0, 1, and 540. So again, double check that by using your calculator. But there we go. So there's my new table. We now scan through the bottom row to see if we have any negatives. And we do. We have 2 negatives here. So which one is our largest negative? That would be the negative 2. So that has to be our pivot column. Now we got to figure out what is our pivot row. So let's take a look. We have 90 divided by a half. That gets me 180. And we got 210 divided by 5 halves. And that's 84. And then we'll have 60 divided by, well, this is a 0. And remember that the entry in the pivot column must be positive in order to be a pivot element. So now that, because this is 0, it doesn't count. So 84 is the smallest one, so this is my pivot element. Now I need to turn this into a positive 1. So what I'm going to do is I'm going to multiply row 2 by 2/5. And if I do that, because 2/5 times 5 halves will be a 1. So I'm now going to get 0, 1, 3/5, negative 1/5, 2/5, 0, 0, and 84. Now nothing's changing to the other rows, so let me just write those back in. Okay, now that's done. Again, our pivot element is right here. So let's get started with our operations. We need to make this and this into zeros. So let's bring this table up top. Now I don't need to change anything to row 2 because it's our pivot row. So I put that in there already. So let's talk about row 1. Now I want to change row 1. It's a 1/2. I need the 1/2 to turn into a 0, so I'm going to subtract 1/2 times your pivot row. And if you do that correctly, you will get 1, 0. You'll get a 1/5, 3/5, negative 1/5, 0, 0, 48. All right, let's take a look at row 3. Row 3 is already a 0 here, which means we don't have to do anything to it. So let me just write that back in. and row 4. Now row 4 has a -2. I need that to become a 0. So we're going to take row 4 plus 2 times row 2. Again, our pivot row is row 2. And if you do this correctly, you'll get 0, 0, 1/5, 13/5. Again, I'm doing all this on the graphing calculator. I've showed you plenty of times now. But because you get so many fractions when doing the simplex method, it's a good idea to use the graphing calculator. Okay, so we are now done, because notice that when you scan through the bottom row, there are no negatives. So we know we are done. Now we just got to read off our answer. So remember, we have our basic and non-basic columns. All right, this is I'm going to put a B for basic, basic, and then basic. And actually, technically, this is basic as well. Okay, so we have x, there's my x, is going to equal 48. We have y, which is right here, and that's going to equal 84. Now what about z? Well, z is in a non-basic column. Notice it's our junk column. And any variable that's from a junk column will be 0. All right, so this is our answer, and our max, because this was a maximum problem, the max is 708. That is our max right there. So what about u, v, and w? Well, u is 0. I'll put that down here. U is 0. V is 0. What about w? Well, w is actually a basic column. It's a unit column. So w is actually 60.